to respected panel. Today I, Muhammad Syariah Afiq bin Nasruddin, matric card number AA16028, is going to present about my final year project topic, which is Phytoremediation process for removal of pollutant from rare earth refining industrial wastewater using Neptunia Oleracea. As an introduction to the topic, as Malaysia is quick turning into an industrialized country, a large number of the streams have gotten dirty due to the numerous condos that have been emptied into the waterway. This polluted wastewater may come from various sources, which include industrial areas such as rare earth refining industrial wastewater in the Lighthouse project. The problem statement here is there is some concern regarding the possible leakage of heavy metal into Kuantan area, and also regarding the declining of the quality of the water source. The significance of this study: first, we able to understand the process of phytoremediation in wastewater treatment, increase the potential of reducing wastewater issue in selected area, and able to identify current condition of wastewater in the area. Next, we go into the objective. The objective of the study is first is to identify the level of pollutant that contain in the rare earth refining industrial wastewater for baseline information. Second is to identify the efficiency of Neptunia Oleracea to remove the pollutant contained in the wastewater. The scope of the study is focusing on the rare earth refinery activities in Gebeng area, in which the water sample will be collected at the area before lab testing will be conducted in Fukasa Lab UMP. The result obtained from this testing will lead to obtaining the removal efficiency of the pollutant removal of the plant. Next, we going to the literature review. These are the literature review regarding this topic, in which will be helpful during this study. One of the outcome from the previous study is in 2012, in which Bisachi et al. Having the outcome which said that the water mimosa has ability to accumulate heavy metals such as lead, copper, cadmium and zinc, and is a good accumulator of cadmium and copper. Besides that, Nurhani et al. In 2012 come with the outcome from her study that said that this plant is useful for phytoindicator for ammonia and phosphate contaminant. Next, I will be explaining the methodology part, in which the flowchart starts from the selection of title and study area to gather information, selection of aquatic plant, collection of water sample and plant, experimental setup, record data analysis, data collection, removal efficiency calculation, and the last part is recommendation and conclusion. Let's take a look to the study area, in which the study area is in rare earth refinery project in Gebeng industrial area, in which wastewater will be collected near the location. In the sample collection aspect, the wastewater will be collected at the selected area with a total volume of about 25 liter, in which the sample will be used for lab testing. For the collection of the plant will be collected at Agrofarm in Serdi Menanti, Negeri Sembilan. Sufficient amount of plant will be used for this lab testing. Next, we go into the experimental setup. First, 4 different mixture of wastewater plus distilled water is placed in the water, in which 3 of the water container contain aquatic plant, in which it is 100%, 75% and 50% of water container, while 1 water container act as the control. Neptunia Oleracea will be placed in water container that fill with distilled water for 3 days, and the plant will be placed in each of the water storage, and testing will be conducted for week 0, 1 and 2. For data analysis part, the lab testing will be conducted for 2 weeks for all parameters. The data record will be used to create the graph for the removal of percentage of each parameter against week. The parameter which will be involved in this lab testing include COD, BOD, TSS, turbidity, ammonia, nitrogen, pH, and heavy metals such as lead, copper, and cadmium. This is the result that have been recorded for each week, in which the graph of percentage of removal of parameter is also shown in the slide. For the COD parameter, the removal of percentage is higher in the water container that contain aquatic plant, in which the value of removal is more than 30%, while control container only about 20% of removal. The highest percentage of removal is in 100% water container, which is 49.40%. Meanwhile, for BOD parameter, the removal of percentage is higher in the water container that contain aquatic plant, in which the value of removal is more than 45%, while control only about 35% of removal. The highest percentage of removal is 100% water container, which is 55.41%. Both COD and BOD result obtained show that the result is the same as the previous research outcome, which is this plant can help in removing COD and BOD. For the turbidity parameter, the removal of percentage is higher in the water container that contain aquatic plant, in which the value of removal is more than 35%, while control container only about 20% of removal. The highest percentage of removal is in 100% water container, which is 52.52%. Meanwhile, for TSS parameter, the removal percentage is higher in the water container that contain aquatic plant, in which the value of removal is more than 78%, while control container only about 42% of removal. The highest percentage of removal is 100% water container, which is 86.21%. These results show that this plant helps in making water clearer. For ammonia nitrogen parameter, the removal of percentage is higher in the water container that contain aquatic plant, in which the value of removal is more than 67%, while control container only about 50% of removal. The highest percentage of removal is 100% of removal, which is in 75% and 50% of water container. Meanwhile, for heavy parameter, which is copper, the removal of percentage is higher in the water container that contain aquatic plant, in which the value of removal is more than 77%, while control container only about 38% of removal. The highest percentage of removal is 50% water container, which is 85.71%. For the lead parameter, the removal of percentage is higher in the water container that contain aquatic plant, in which the value of removal is more than 55%, while control container only about 34% of removal. The highest percentage of removal is 100% water container, which is 61.11%. As for cadmium, the removal of percentage is higher in the water container that contain aquatic plant, in which the value of removal is more than 52%, while control container only about 35% of removal. The highest percentage of removal is 50% water container, which is 73.02%. From this heavy metal result, it shows that this aquatic plant does help in reducing pollutant in the wastewater. As for the pH parameter, it shows that pH is turning into alkaline after 2 weeks. This pH value is actually affected by the temperature, in which when the temperature decreases, the value of pH will increase. As a conclusion, the level of pollutant in the industrial area selected is identified, as the value recorded is used as initial week, which is week 0. The phytoremediation using Neptunia Oleracea proved to be effective in phytoremediation process to remove pollutant in the wastewater. This aquatic plant is most suitable in 100% water container, as the result of parameter mostly show higher removal of percentage of parameter occur in the container. As a recommendation that can be suggested to improve the accuracy data obtained and the study of the aquatic plant, first, modification of percentage mixture of wastewater, dilution water and plant in each of the water container can be done. Second, research on different pre-treatment method for heavy metal removal also can be done. And last but not least, modification to the duration of the research to be conducted is also can be done to get a better and improved data. That's all for me. Thank you. Assalamualaikum.